Hello class, Mr. McRae here again doing another video. As you can see, I have a different headset, so I'm going to try a different headset this time to make sure, see if it plays better. All right, so today we're going to be talking about square roots and radicals. So I did some pre-work here so you guys get a quick understanding and some background information, and then we'll get into some problems, okay? So square roots are radicals. What is it? So square roots are basically a number multiplied by itself. Okay, and the radical portion is basically the square root on top. So that would actually be the radical. Is that little like the sign and that little thing bar over the tops. Okay, so we should know how to do a square root. So the idea is basically a number multiplied by itself. So we have the square root of 36. So we have to ask ourselves, what what is 36 multiplied by itself? It's obviously 6. Okay, so we know that from a long time ago. But it also can be -6 as well. Okay, because -6 times -6 is positive 36. But we're not getting to that point yet. Okay, all right, so that's a little higher level. All right, so again, square root of 16, we know what that is. That's going to be 4, okay, because 16, number multiply itself is 4 times 4, so 4 is going to be pulled out. Okay, so now let's look at the value of, we got square root of 12, okay? Now, how do we solve this one? Okay, so again, we have the idea of, okay, what number, this is not a perfect square, so the number can't be multiplied by itself. So what we have to use is what is called the product property of radicals. And basically what that means is that if you have a value or values underneath a radical, they can be broken apart and multiplied together. Okay, so you can take the square root of A times the square root of B. So think about it. In terms of this question, we have square root of 12. Okay, now how can I break this apart to make it workable? Okay, we have square root of 4 times the square root of 3. Both things are factors. You could have done 6 and 2, but 4 is easy because that's a perfect square. Now, from here, what's the square root of 4? Okay, we should know that easily. That's 2. Okay, and then we have the square root of, and then we have the square root of 3, which can't be broken down. So we end up with 2 square root 3. Okay, so that's what we're going to be talking about today, is how to do problems like this. Okay, and work them through them. We're also going to talk about variables as well to give you an understanding of that. It's kind of higher level, but I think it's a good time to introduce it so you guys can get good at it as we go along. Okay, so what I did was also I prepared a bunch of steps for you guys to see. Okay, and how to actually simplify a square root. So I'm going to read off these steps, and this is what I'm going to be practicing when we do the practice. Okay. So we have step 1 is basically you want to check for a perfect square. So when you have a number, you want to check to see if that number can be simplified into a perfect square, okay, or a factor of a perfect square, okay? Sorry, a factor of a perfect square. Now, what's the second step? We want to find the factor that is a given number and write that number under the first radical. So the first one we want to find is the factor. It's got to be that perfect square number that we want to find, okay? Second, we want to take the second factor and write it under radical as well. Okay, so we have 2 factors. To call it similar to, and how we're going to do is called prime factorization, so which we did in the do now. So guys should be pretty familiar with it as we go along. Okay, and then we're going to simplify, and then we're going to combine. Okay, and that's it. So those are the 4 steps. Check for a perfect square, find the factor of the given number and write the number under the first radical, second factor under the radical, simplify and combine. That's it. Okay, that's it. All right. So let's get moving on as we go along in the process here. So here's the information that you really need to know, and I'd like you to write that down. I'm going to stop the tape. I'm going to stop the video at this time, and you're going to write this down. This is very critical. Okay, this is the perfect square number line. Okay, so what do you mean? Okay, so we have square root of 0, square root of 1, square root of 4, square root of 9, square root of 16, 25, 36, 49, 64, 81, and 100. Okay, I can go higher than that, but I don't think we need it. All right, so looking at, so again, basically, remember what square root is. Basically a number that can be multiplied by itself. So what value can be multiplied by itself to equal 0? 0 times 0. 1, 2, square root of 4 is 2, square root of 9 is 3, square root of 14. I think we can read how this goes on and on and on. So again, these are the simplest ones. And again, I'd like you to write those down because you're going to need those when you do your work, when you start simplifying this work here. Okay? All right. So let's move on into the actual work. I know I'm kind of going fast, but hopefully you guys can get most of this information. I think some of you guys had this in Matt and Richmond as well. So let's look at the first question, okay, an example. Okay, we have the square root of 72. Okay, so the first step is you want to find it you want to check to see if it's a perfect square. So if I look on this number line here, I have 72. 72 is between 64 and 81, and that's not a perfect square, so I know it's not a perfect square. So if I want to estimate that by using this perfect square number line, I can see that it's 8 more away from 64, and it's 9 away from 81. So that's like 8.4. If I want to approximate that, okay, that's how you actually think about it. If you want to actually estimate what it is, it'd be like you take the square root of 72, you should get 8.4 something, okay, or maybe 8.5, whatever, okay? So that's the approximation way of doing it. All right, but we're trying to simplify, okay? So what do we have to do? So the first thing is we want to look for a perfect square within this that can be broken down into using prime factorization, okay? So prime factorization, again, we make the two lines here. What are the two factors? Okay, so let's look here, okay? We start at 100, let's start at 64. Can it break down? No. 49 can't break down. 36 can break down, though. Square root of 36, okay? Because 36 times 30 plus 36 equals 72. So I'm going to use that. Square root of 36. And then I'm also going to put square root of 2, because that's what the product property of radical says. I can break down 72 into two separate radicals, or separate square roots. Okay, so now once I do that, now I can think about, okay, what's the so the third step is first step is to write this perfect square. Second step is write the other radical right here, and then you want to figure out if you can simplify either one of them. Okay, so square root of 36, I know I can simplify because that already breaks down to 6. Okay, so I'm going to write this down as 6. Okay, now, and I'm going to check this. Okay, now I like checking things, so I'm going to check this here. Okay, now what about the square root of 2? Square root of 2 is between 1 and 4, and again, that could be like 1.3 on this side if I want to approximate that. But I'm not here to approximate, I'm here to do some work. So can I actually break this down? Nope, I can't, so it's going to stay where it is. So now I'm going to combine both of these values by multiplying. So it would be 6 square root 2. Okay, 6 square root 2 would be the answer to that question. So 6 times the square root of 2 would give us the approximation of 8.4. That's how it works. Okay, so, but again, you don't have to use the 36. You could also do it this way, okay, just to give you some idea. But it's just the longer steps. I can do 8 and 9. Okay, I can do that. And then a 9, I know that's a perfect square, so that's 3. But now I got to break this down, this 4, because I got to simplify this. This 2, and this becomes the square root of 4. And this becomes 2. So I can check this off, check this off, and check this off. Now I have to multiply these 3 and 2 together and keep this, and that will give me the 6 square root 2. So you can do it the other way too. If you know other factors, you'll get the same answer. It's just a lot of different steps. Okay, so don't be afraid if you don't find the highest perfect square. But I'm doing that right now, but don't understand you don't have to. Okay, so let's look at the next one, 98. So 98 is close to 100, so the approximation of that would be like 9.8 or something like that, close to 10, maybe 9.9 something and some other change. Okay, so an approximation is basically what I'm saying is I'm taking a calculator and I'm putting in the square root of 98. It's going to give me a long, huge value of like 9.8 something. Okay, but I'm not here to do that. My job is to simplify it. Okay, and using the prime factorization. All right, so I'm going to look at 98, and I'm going to look down to see what perfect square will fit into this. 81, no. 64, no. 49. 49 times 2 is 98. So I'm going to use 49. So square root 49, and then I'm going to times that by the square root of 2. Okay? So the square root of 49 is what? Okay, square root of 49 is what? 7. Okay? Because that's a perfect square. And then we have the other one, this square, square root 2. And that's the answer to the question. Okay? That's how it works. All right, and combine. Next one, we have 200. Okay, now if I kept going up 11, 12, 13, I think 14, like 14.5, I think it worked, brother. 14 times 14 is 196. So that's pretty close. I think, yeah, about that. 14, yeah. Yeah, I think that's about right. Okay. So yeah, 14.1, I want to say. I don't know. I'm guessing on the approximation. All right, so let's look for the perfect square. So the first one we see is 100. That's perfect. No pun intended. Okay, so square root of 100, square root 2. Multiply those two together. Okay, now square root of 100, what does that break down to? The perfect square is 10. Okay, and the 2 stays where it's at, so it becomes square root 2. Okay, so that would be the answer to the question. 10 square root 2, 7 square root 2, 6 square root 2. Okay, I think we kind of get the idea of how we're going to do this, all right, in the work. All right, so now I put in some variable ones, okay, to make this a little challenging, a little bit more challenging. Okay, so what about this? We have the square root of x squared. Okay, the square root of x squared. That's a lot of squares in there, a lot of squares. Okay, but how do we break this down? Well, think about what is the perfect square of x squared. What is x squared? How can I break that down? So if I think about it, okay, I'm just going to make one radical to make people see it. It's basically x times x, right? Okay, so x times x equals x squared. Pretty easy, right? So therefore, if I know that these two they're basically the numbers that multiply against itself is the rule of square roots. So this breaks out to just being x. Okay, so square root of x squared is x. Okay, it just breaks out to be x because there's two perfect squares. All right, hopefully you get that. We'll practice it. Okay, now let's look at another one. Let's go the square root of x to the third. Okay, what is it going to happen here? Well, think about what the product property rule of radicals says. I can break them down into two separate square roots, and then I can simplify. So what is this? Basically, I can break this down to be square root of x, square root of x squared. Okay, that means the same thing as x to the power of 3, right? Remember back from our work with law of exponents. Okay, multiplication rule. We can multiply both these numbers together. It's going to add the exponents. Ooh, see how it comes back to you. All right. So what do we know about x squared? X squared is going to equal x, okay, because that's a perfect square. So we're going to break that out. Okay. Now, what about square root of x? Well, you can't really break down the square root of x, so that's going to be the same where it's at. So boom, boom. Okay, we got both of them. So how do we put this together? So x to the third, square root of x to the third is going to be x square root x. Okay, x square root x. Okay, does everybody see that? Everybody see how that works? All right, and that's how it goes. All right, guys. Actually, I'm going to do one more problem so we can actually get a real picture of this, and I was going to move it on. One more problem. Okay, so here's another example. Okay, this is where we're going to go to the harder problems. Square root of 18 x to the third. Okay, so how do we break this down? Okay, so remember, product property of radicals says I can break these down into two separate parts. I can break this down to square root of 18, and this can be square root of x to the third. Okay, then I can use the look on here for the perfect squares. So the perfect squares for 18 is 9, square root of 9, and the square root of 2. So I'm going to put that down. Square root of 9, square root of 2. Okay? Now, square root of 9 is obviously a perfect square, so that breaks down to 3. And then the square root of 2 stays where it's at. Now, let's work with square root of 3. So we said that before. It can be broken down to square root of x times square root of x squared. Okay? So from here, okay, x squared, x, all right? Now, what do we know about x squared? X squared can be broken down as a perfect square to x. And then we can keep this the same because it's x squared. Now, how do we put all the checks together? Okay, so we have 3 and x on the outside, and we put these two together in the inside. So it becomes 3x on the outside, square root 2x. and that would be the answer. Okay, so that's what we're going to get to at the end of this. In a couple, and probably about next week, we should be able to get to that and be able to do that efficiently. Okay, so that's what we're going to end up at. All right. So again, thanks, guys, and we'll talk to you guys soon. And hopefully, we will have a good day in the rest of your classes. Bye.